Hello everyone, welcome to Medis Global. For the mathematics, we have prepared total 6 parts. Here this is the first part in which we will cover all the important formulas and the short notes for the linear algebra. So let's start one by one. Here the first topic is matrix. So in the matrix, first one is the definition. It is a system of mn numbers arranged along m rows and n columns. Conventionally, you can say that single capital letter is used to denote a matrix. And here, as you can see, that this is the standard representation of matrix. Then after types of matrices, first one is row and column matrices. So in the row matrix, as you can see here, it is only a single row or single vector. You can say that single row vector. Then in the column matrix, here it is the vertical single column is there, or you can say that column vector. Here we have provided the short notes from very basic points, so you need to keep some patience if you are already aware of this type of matrix. Here the next type is square matrix. So for the square matrix, these are the properties. First one is the same number of rows and columns, then order of square matrix is equals to number of rows or columns. Then after principal diagonal, here it is the diagonal of a square matrix, which is known as the principal diagonal. Then the trace of the matrix is the sum of the diagonal elements of a square matrix. So here it is the representation of the trace, and these properties are important for the examination. Trace of lambda is equals to lambda into trace of a. Here lambda is scalar. Then after trace of a plus b is equals to trace of a plus trace of b. Then trace of AB is equals to trace of B into A. So these are the properties for the square matrix. Then after for the rectangular matrix, number of rows is not equals to number of columns. Then the next one is diagonal matrix. So for the diagonal matrix, it is a square matrix in which all the elements except those in leading diagonal are 0. Here the example is also given. Now let's move towards the next one. Here the next matrix is unit matrix, or you can say that identity matrix. It is a diagonal matrix in which all the leading diagonal elements are 1. Here for example, here 3 cross 3 identity matrix is given. Then after the next one is null matrix, or you can say that 0 matrix. In this matrix all the elements are 0. Then after next one is symmetrics and skew symmetric matrices. Here for the symmetric matrices, Aij is equals to plus Aji for all I and j. In other words, A transpose is equals to A. And for the skew symmetric matrix, when Aij is equals to minus Aji, then A transpose is equals to minus A. So these two are the examples of the symmetric and skew symmetric matrices. And remember this condition: for symmetric matrix, A transpose is equals to A, and for skew symmetric matrix, A transpose is equals to minus A. Then after the next one is triangular matrix. A matrix is said to be upper triangular if all the elements below its principal diagonal are 0. And a matrix is said to be lower triangular if all the elements above its principal diagonals are zeros. Here two examples are also given for the upper triangular matrix and the lower triangular matrix. Then after the next one is orthogonal matrix. Here if A into A transpose is equals to identity matrix, then the matrix A is said to be the orthogonal matrix. Similarly for the singular matrix, if mod A is equals to 0, then A is called a singular matrix. Then after next one is unitary matrix. If we defined A theta is equals to A bar transpose, which is equals to transpose of a conjugate of matrix A, then the matrix is unitary if A theta into A is equals to I, where I is equals to identity matrix. Once again, from these types of matrix, there are so many times questions were asked, so all these matrices are important for the examination. Here the next one is Hermitian matrix. It is a square matrix with complex entries which is equals to its own conjugate transpose. Here a theta is equals to a, or you can say that aij is equals to aij bar. Here note that in Hermitian matrix diagonal elements are always real. This question was asked more than 2 times in the examination. Then after next one is skew Hermitian matrix. It is a square matrix with complex entries which is equals to the negative of conjugate transpose. Here a theta is equals to minus a, or you can say that aij is equals to minus aji bar. Here note that in the skew Hermitian matrix diagonal elements are either 0 or pure imaginary. This question was also asked in the examination. So for the Hermitian and skew Hermitian, these two conditions you have to remember, as well as these two notes are also important for the examination. Then after the next one is idempotent matrix. If a square is equals to a, then the matrix A is called the idempotent matrix. So these are the important types of the matrix. Now the next topic is multiplication of a matrix by a scalar. Every element of the matrix get multiplied by that scalar. Here multiplication of matrices, in that two matrices can be multiplied only when the number of columns of the first matrix is equals to the number of rows of the second matrix. Multiplication of m cross n and n cross p matrices results into the m cross p. Here this rule is most important for the examination because based on this rule the directly questions can be asked in the examination, and till now more than 6 to 7 questions were asked from this topic. Then after determinant, here an nth order determinant is an expression associated with n cross n square matrix. If A is equals to aij, then for n is equals to 2, determinant of A is equals to a11, a12, a21 and a22. So for this matrix you can find the determinant by a11 into a22 minus a12 into a21. Similarly for 3 cross 3 you can solve the determinant. These determinant solving are very easier in the examination because from 11th and 12th standard we are solving the determinant for the matrix. Then the next one is minors and cofactors. Here the minor of an element in a determinant is the determinant obtained by the deleting the row and the column which intersect that element. Then cofactor is the minor with proper sign, and the sign is given by minus 1 raised to I plus j, where the element belongs to ith row and jth column. Then here this is the most important topic, which are the properties of determinants. There are 13 properties are here. First one is a determinant remains unaltered by changing its rows into columns and columns into rows. Then second one is if two parallel lines of a determinant are interchanged, then the determinant retains its numerical values but changes its sign. In general manner, row or column is referred as a line. Then third one is determinant vanish if two parallel lines are identical. Then if each element of a line multiplied by the same factor, then the whole determinant is multiplied by the factor. Here note that it is the difference with matrix. Then if each element of line consists of the m terms, then determinant can be expressed as the sum of the m determinants. Then if each element of line be added equimultiple of the corresponding elements of one or more parallel lines, then determinant is unaffected. For example, by operation R2 to R2 plus VR1 plus QR3, then determinant is unaffected. Then next one is determinant of an upper triangular or lower triangular or diagonal scalar matrix is equals to product of leading diagonal elements of the matrix.
Then if A and B are the square matrix of the same order, then determinant of A into B is equals to determinant of B into A is equals to det of A into det of B. The ninth one is, if A is non-singular matrix, then A inverse is equals to 1 upon determinant representation. Then after the determinant of a skew symmetric matrix, for example, A transpose is equals to minus A. For the odd order, here the determinant is 0. Then if A is a unitary matrix or orthogonal matrix, then determinant of A is equals to plus or minus 1. Then if A is square matrix of order n, then det of k into A is equals to k raised to n into determinant of A. Then the last one is determinant of I of n is equals to 1, where I of n is equals to identity matrix of order n. Here all the properties are important, but mostly in the examination from 8 to 12 properties, there are so many times questions were asked. Then the next one is inverse of a matrix. A inverse is equals to adjoint A divided by determinant of A. Here determinant of A must be a non-zero. Then inverse of a matrix, if exists, then it is always unique. Then if it is a 2 cross 2 matrix, then its inverse will be 1 upon AD minus BC into D minus C minus B and A. So these are the representation for the inverse of matrix. Then after important points, here first one is I into A is equals to A into I is equals to A. Then second one is 0 into A is equals to A into 0 is equals to 0. Here 0 is null matrix. Then if AB is equals to 0, then it is not necessary that A or B is null matrix. Also, it doesn't mean that B into A is equals to 0. Then if the product of two non-zero square matrices A and B is 0 matrix, then A and B are singular matrices. Then if A is non-singular matrix and A into B is equals to 0, then B is null matrix. Then AB is not equals to BA, then in general, cumulative property does not hold. The next one is A into BC is equals to AB into C, then associative property holds. And the last one is A into B plus C is equals to AB plus AC, then distributive property holds. Then some more notes are here. If AC is equals to AD, it doesn't implies that C is equals to D even when A is not equals to 0. Then if A, C, D be n cross n matrix, and if rank of A is equals to n and S is equals to AD, then C is equals to D. The next one is A plus B transpose is equals to A transpose plus B transpose. Then AB transpose is equals to B transpose into A transpose. Then AB inverse is equals to B inverse into A inverse. Then A into A inverse is equals to A inverse into A is equals to I, where I is equals to identity matrix. Then next one is transpose of K into A is equals to K into A transpose. Then inverse of K into A is equals to K inverse into A inverse, where K is scalar and A is vector. Then transpose of A inverse is equals to inverse of A transpose. Then A transpose bar is equals to A bar transpose. Here conjugate of a transpose matrix is equals to transpose of a conjugate matrix. Then if a non-singular matrix A is symmetric, then A inverse is also symmetric. Then if A is orthogonal matrix, then A transpose and A inverse are also orthogonal. Then last one is if A is a square matrix of order n, then first one is determinant of adjoint A is equals to determinant of A raised to n minus 1. Then second one is determinant of adjoint A is equals to determinant of A raised to n minus 1 square. Then third one is adjoint A is equals to determinant of A raised to n minus 2 into A.
Then next one is elementary transformation of a matrix. Here first step is interchange of any two lines, then multiplication of a line by a constant, then addition of a constant multiplication of any line to the another line. Here note that elementary transformations don't change the rank of the matrix. However, it changes the eigenvalues of the matrix.
Now here it starts the most awaited topic of the lecture, which is rank of the matrix. This is the most important topic as well. If we select any r rows and r columns from any matrix A, then deleting all the other rows and columns, then the determinant formed by this r cross r element is called minor of A of order r. Here the definition is a matrix is said to be of rank r when it has at least one non-zero minor of order r, and the second one is every minor of order higher than r vanishes. Here other definition is the rank is also defined as the maximum number of linearly independent row vectors. Then here one special case, rank of square matrix. Rank is equals to number of non-zero row in upper triangular matrix using elementary transformation. Here some notes are there. First one is rank of A into B is less than or equal to minimum of rank of A or rank of B. Then after, the rank of a diagonal matrix is simply the number of non-zero elements in principal diagonal. Then a system of homogeneous equations such that the number of unknown variable exceeds the number of equations necessarily has non-zero solutions. So in general, for finding the rank of a matrix, here it is the number of non-zero rows in its row echelon form, or in the other words you can say that it is the maximum number of linearly independent row vectors. Then the next one is if A is non-singular matrix, then all the row or column vectors are independent. Then after, if A is singular matrix, then vectors of A are linearly dependent. Then after, rank of A is equals to 0 if and only if A is a null matrix. Then after, if two matrices A and B have the same size and the same rank, then A, B are the equivalent matrices. And the 10th one is every non-singular matrix is a row matrix and it is equivalent to identity matrix. Now the second last topic of this lecture is solution of linear system of equations. As you all know, from this topic, every year there may be one or two questions definitely will be asked in the examination. So first one is, here it is the representation of the A into X is equals to B. Here A is equals to coefficient matrix and R is equals to rank of A and R dash is equals to rank of C. Then C is equals to A and B. Here C is equals to augmented matrix and N is equals to number of unknown variables. Here consistency of a system of equations. Here first one is for non-homogeneous equations. So Ax is equals to B. There are three cases for the non-homogeneous equations. First one is if R is not equals to R dash, then the equations are inconsistent, or you can say that there is no solution. Then second one is if R is equals to R dash is equals to N, then the equations are consistent and there is a unique solution. Then third one is if R is equals to R dash and less than N, then the equations are consistent and there are infinite number of solutions. Here R dash is equals to the rank of augmented matrix. Then after, next one is for the homogeneous equations, or you can say that Ax is equals to 0. Here there are two cases. First one is if R is equals to N, then the equations have only a trivial 0 solution. Then second one is if R less than N, then N minus R linearly independent solution. So here infinite non-trivial solutions.
Here note that in the case of homogeneous equation, there is no case of no solution. There is always one solution exists. These 5 conditions every aspirant should remember by heart because this is very important for the examination. Then here note that consistent means one or more solution, or you can say that unique or infinite solution, and inconsistent means no solution. The next one is Cramer's rule. Let the following two equations be there. a11x1 plus a12x2 is equals to b1, and the second one is a21x1 plus a22x2 is equals to b2. Then determinant is equals to a11 a12 b21 b22. Then after d1 is equals to b1 a12 b2 a22, and d2 is equals to a11 b1 a21 b2. Then solution using Cramer's rule. x1 is equals to d1 by d and x2 is equals to d2 by d. In the above method, it is assumed that first one is number of equations is equals to number of unknowns, and second one is mod d, or you can say that determinant is not equals to 0. So using Cramer's rule also you can find that there is a single solution or infinite solution. So here these are the conditions. In general, for non-homogeneous equations, mod d is not equals to 0, then single solution or non-trivial solution. Then if d is equals to 0, then infinite solution. Then for the homogeneous equations, if d is not equals to 0, then trivial solutions, and d is equals to 0, then non-trivial solution or infinite solution. So these two are the method. First one is by finding the rank you can find the solutions, and in the second method you can use Cramer's rule also. And the next one is eigenvalues and eigenvectors. This is the last topic for this lecture. Here this is also very important for the examination. From this topic also there are so many times questions were asked. So first one is characteristic equation for the eigenvalues. Here determinant of a minus lambda I is equals to 0, and the roots of this equation are called the characteristic roots or latent roots or eigenvalues of the matrix A. Then after the eigenvectors, here a minus lambda I into x is equals to 0. For each eigenvalue lambda, solving for x gives the corresponding eigenvector. Then here note that for a given eigenvalue there can be different eigenvectors, but for the same eigenvector there can't be different eigenvalues. This note is very useful in the examination. Then after there are some for the eigenvalues. Here first one is the sum of the eigenvalues of a matrix is equals to the sum of the principal diagonal. Then second one is the product of the eigenvalues of a matrix is equals to determinant. Then the largest eigenvalue of a matrix is always greater than or equal to any of the diagonal elements of the matrix. Then fourth one is if lambda is an eigenvalue of the orthogonal matrix, then 1 by lambda is also its eigenvalue. Then if A is real, then its eigenvalue is real or complex conjugate pair. Then next one is matrix A and its transpose AT has the same characteristic root, or you can say that eigenvalues. Then next one is the eigenvalues of a triangular matrix are just the diagonal elements of the matrix. Then 0 is the eigenvalue of the matrix if and only if the matrix is singular. Then eigenvalues of a unitary matrix or orthogonal matrix has absolute value 1. Then after next one is eigenvalues of Hermitian or symmetric matrix are purely real. Then next one is eigenvalue of skew Hermitian matrix or skew symmetric matrix is 0 or pure imaginary. And the next one is determinant of A by lambda is an eigenvalue of adjoint A, because adjoint A is equals to det of A into A inverse. Then this is most important for the examination. Here if lambda is an eigenvalue of the matrix, then here 5 properties are there. First one is eigenvalue of A inverse is equals to 1 by lambda. Then eigenvalue of A raised to m is equals to lambda raised to m. Then eigenvalue of Ka are k lambda, where k is scalar. Then eigenvalue of A plus Ki are lambda plus k. Then eigenvalue of a minus ki square or lambda minus k square. So these 5 properties you have to remember for the examination. And these are some important properties for the eigenvectors. Here first one is eigenvector of X of matrix A is not unique. Here let xi is eigenvector, then cxi is also eigenvector, where c is equals to scalar constant. Then if lambda 1, lambda 2, lambda 3 up to lambda n are distinct, then x1, x2 up to xn are linearly independent. Then third one is if two or more eigenvalues are equal, it may or may not be possible to get linearly independent eigenvectors corresponding to the equal roots. Then fourth one is two eigenvectors are called orthogonal vectors if x1 transpose into x2 is equals to 0. Then here note that for a single vector to be orthogonal, A transpose is equals to A inverse, or A into A transpose is equals to A into A inverse is equals to 1. Then eigenvectors of a symmetric matrix corresponding to the different eigenvalues are orthogonal. Then here Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. So you can replace A by lambda. Then here the next topic is vector. It is any quantity having n components is called a vector of order n. Then linear dependence of vectors. If one vector can be written as linear combination of others, then the vector is linearly dependent. Then linearly independent vectors. If no vectors can be written as a linear combination of others, then they are linearly independent. Then suppose the vectors are x1, x2, x3, x4, then its linear combination is lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus lambda 4 x4 is equals to 0. Then if lambda 1, lambda 2, lambda 3, lambda 4 are not all 0, then they are linearly dependent. And if all lambda are 0, then they are linearly independent. So this is all about the first part of the linear algebra, in which we have covered the types of matrices, then after determinant and properties of determinant, then after the system of linear equations, then after rank of matrix, then after eigenvalues and eigenvectors. So if you like this video, please do like and subscribe for the upcoming videos, in which we'll discuss about probability distribution. So keep sharing this video to all your study groups. Thank you so much for watching the video. Good luck.